Have you ever wanted to get a bunch of devices talking to each other wirelessly, but maybe it sounded too complicated or you thought all the hardware would cost too much? Well, guess what? It's not as hard as you might think, especially using the ESP-NOW wireless protocol. In this video, we're going to go through the simplest way to get started with ESP-NOW. By the end of this video, you'll know exactly what hardware you need, you'll know how to set up the Arduino IDE, how to load the code onto your ESP devices, and the exact sketch you should try first to get started. And to top it all off, I am going to drill into your brain the handful of functions from the ESPNOW API that you need to use in order to make all this magic happen. Stay tuned. Before we start, I want to say a huge shout out to Altium for sponsoring this video. If you want to get a free trial of their PCB design software, that's a free trial. Check out the description below for our link. And while you're down there, hey, subscribe to the channel and like the video. I'd really appreciate it. And if you have any questions throughout this whole video, make sure to leave a comment, ask a question. We really do our best to reply to all the comments. And finally, if you're diving into this Arduino stuff and you really want to learn the ins and outs, make sure to check out our training program. You can learn more about that in the description. All right, let's get started. Now, you may be familiar with ESP boards like the ESP8266 and the ESP32. These have made a real splash because they're super cheap microcontrollers that are Wi-Fi enabled. Makes it super easy to make projects that are connected to the internet. But you might be a little hazy about this whole ESP-NOW thing. You might be thinking, is this like late night owl wrestling on ESPN? No, it's actually not that. ESP-NOW is a different protocol that's been developed by Espressif, which is the company that makes these ESP boards. And what it does is enable multiple of these ESP devices to communicate with one another without using Wi-Fi. It's a protocol that's similar to a low-power 2.4 gigahertz wireless connectivity that you might see used in like wireless mouses. But the bottom line is you can use the ESP-NOW protocol to get a bunch of these devices to send information back and forth, which is fantastic if you want to build some type of wireless sensor network. Now, the size of information that you can send from one device to another is like 250 bytes. So you're not going to be streaming video or voice from one ESP unit to another. But 250 bytes is plenty if you want to send sensor readings or any other type of information that can be fit in a smaller packet. Okay, now that we've cleared that up, let's go ahead and jump into the steps to get you up and running with ESP-NOW as fast as possible. All right, step one, you need to get your hands on at least 2 ESP32s or 2 ESP8266 development boards. I'm going to be using ESP32s as we walk through this. Now, you can get these development boards just about anywhere. You can find them on Adafruit, SparkFun, Amazon, ESPN. They come in all different flavors and sizes, and we'll link to some of the common ones below. But in the development board you do choose, I'd recommend these two features. The first is that they have a USB port that you can attach to, so you don't need some type of special cable to program them. And two, that they've got a place where you can connect a lithium polymer battery. That just makes it easier to deploy them as part of a wireless sensor network. Step two, you need to set up the Arduino IDE to work with the ESP32 and or the ESP8266. Now this takes all of 30 seconds and I will link to a video in the description where we walk through how to do it in detail. But all you have to do is this. You open up the Arduino IDE. You go to File, Preferences. On a Mac, it's Arduino Preferences. Then, down in this space where it says Additional Board Manager URLs, you just paste a URL that I will link to in the description. Once you've pasted that URL down in this little box, then you just go to Tools, Board Manager, search for ESP, and then just select the one you want to install. I've got them both installed already, but you would just click Install. Once you've got that installed, what it does is populate the different board options you have when selecting boards. So you'll have options for ESP32 boards that you might be using. So now we're getting really close to having this up and running, but there are a couple gotchas that will make you want to grab a knife and stab yourself in the heart. But I'm telling you, we can work through this. Okay, I want to approach this in hopefully the easiest way to do this. All right, so you've got two ESP boards. I want you to take one of them and connect it to your computer. Then go up to Tools, Port, and you want to hope that you see your device connected. Now, if you don't see the device that you think should be your ESP32 or your ESP8266, don't fret. Now, there's a couple things you can do if it doesn't show up. The easiest thing to do is just to unplug it and plug it into a different USB slot on your computer. But generally, there's going to be two buttons on these development boards. One is a boot button and the other is a reset button. I'd recommend trying to press that reset button first to see if you can get your board to show up. If that doesn't work, then you can try pressing that boot button to see if that shows up. But you should be able to get that board to show up in your serial ports. And if it's not there first time go, don't sweat it, you'll be able to get it hooked up. The next hurdle you need to overcome is to make sure that you can actually upload code to the board. Because again, in my experience, even if I see the port, sometimes I have an issue uploading code to the board. So what I'm going to do is open up a super simple blank sketch. So I'm going to go to File, Examples, Basics, Blank. And in this Blink example, they use this keyword called LED underscore built in. Now this sketch may or may not run on your ESP board depending on which development board you've got. So I'd recommend looking at the pinout of your specific board. So I'm using the ESP32 and usually they have an onboard LED. So here, this one says there is an onboard LED at pin 5. So I'm just going to replace this with 5. Now I'm going to upload it to my ESP board. So if you run into an error like this, try holding the boot button and then uploading the code. Once you see the upload start, then you can release the boot button. It's just one of those many things out there that if you don't know, you can spend way too much time trying to troubleshoot it and thinking like something's wrong with my board when in fact it's just a pretty common thing that happens. All right, so we've done a smoke test. We can actually upload something to this board. So now what I'm going to do is show you the sketch to start testing out this ESP-now functionality. In fact, there's two separate sketches. One of your ESP boards is going to have the transmit sketch or the master sketch, and the other board is going to have the receiver sketch or the slave sketch. So where you'll go is up to File, Examples, and you're going to scroll down to ESP32, and they've got a ton of examples here. You're going to go to ESP-now, and I want you to check out the basic folder. These are the two sketches. They are going to demonstrate the key functions in this ESPNOW API that are going to help you understand how to set up communication to send information from one device to another. So I'm going to go ahead and open up this master one. Now, it is a pretty big sketch. We're down to about 250 lines of code, and that seems like a lot. But I'll be honest, once you delete all the comments, and there's a ton of serial prints they have in here just for demonstration purposes, this really boils down to a handful of lines of code. But right now, let's go ahead and upload this to the board. Now, if you open up the serial monitor window, you should see some stuff printing out, and it will say that a slave is not found. Try again. Okay, so we've got the transmit code set up on one of the boards. Now what you can do is plug in your other ESP board. Now, what can get really confusing when you start plugging in multiple boards is when you try to pick which one to program, you can get a little confused like, hey, which one is which? So the first time you do it, I would recommend unplugging the one you just uploaded and then plugging in the new board. Call me simple-minded, but it seems to help. If you're looking for electronic parts for your design, you're going to want to check out Octopart. It is a search engine for electronic components. And I'm telling you, it's pretty darn amazing. It's like Google for electronic components. If you want to find and compare parts quickly, there is no comparison. You know, when you're designing something, you don't want to get dragged down by some clunky user interface trying to find the right component. Octopart lets you keep your design momentum going through moments when you used to stop to research components. With every search, you get super important supply chain information like low stock levels and even lifecycle validation checks. Octopart is even integrated with Altium 365, so you can get real-time insight as you design. Make sure to check out octopart.com for finding your next electronic part. So now I've got my other board connected, and I am going to select the board from the Tools menu. So the board I've got connected now is the Unexpected Maker Feather S2, so I'll select that. And then I'll go to Tools, and I'm going to select the port. Here it is, it's marked UM Feather S2, that's the Unexpected Maker Feather, so I'll select that. And then I'll just go to that blank sketch again, that's just File, Examples, Basics, Blank, and then I'll upload it to make sure that it's going to work on this board. And once I'm satisfied that I can upload code to the board, then what I'm going to do is load the receive code up onto this board. So I'm going to go to File, Examples, ESP32, ESPNOW, Basic, Slave, and I'm going to upload this code. So now I've got the transmit code loaded on one and the receive code loaded on the other. I'm going to plug in both of my boards to power. Now they don't have to be plugged into the Arduino IDE, but I do want to check the serial monitor because both of these sketches print some information off and it can help us get an idea to make sure everything is working like we'd expect. So I'm going to go back to Tools, and now I'm going to select the board that has the transmit code, that master code on it. So ESP32 Arduino. So I've got that loaded on my ESP32 thing. Now I'm going to go to Tools, Port, and I'm going to select this port, which I've identified as the SparkFun thing. Now I'm going to open up the serial monitor window, and now we can see we're getting a totally different message here. And this is I found this quite interesting. So it's saying, hey, I found 7 devices. It says it also found a slave device. It gives us the MAC address of the slave device. And a MAC address is basically an address that is physically assigned to each device on the network. It says that the slave status is already paired, and then it says sending 13, and this is just kind of going on and on and on. I turned auto scroll off, but notice we get this error. It says ESPNOW peer channel is not equal to home channel send fail. Send status invalid argument. Now that seems crazy. It says the channels aren't matched. The channel in the slave file is set at channel 1, and the channel in the master file is set to channel 3. So let's go ahead and change this to channel 1, and then we'll upload it to the transmitter board. All right, so now we've made that change. I'll open up the serial monitor window again. So now when we take a look at this, we can see our send status is success, and it tells us the MAC address of the last packet that we sent to. So now if we go over and we change the board to the receiver device and we adjust the port accordingly, and now we're monitoring the serial port for the receiver or the slave, we can see that it gives us a message about the packet it received and the MAC address of the transmitter or the master. So the data that got sent from the transmitter to the receiver is this number 15, and it's just incrementing by 1 every time it sends. So right now, we have 2 ESP devices that are using the ESPNOW protocol. One is transmitting information and the other is receiving it. So of course, it's one thing to have some sketches up and running and sending information. It's another thing to understand what the heck is going on. So what we're going to do is boil down this sketch right here, this master sketch, and we're going to boil down this slave sketch, and we're going to walk through each step in this process. So let me go through. I'm going to take out all of the comments, and the other thing I'm going to do is I'm going to take out some of the stuff in this sketch that's actually really good explanatory stuff. So they have a lot of serial prints in here that let you know why something failed. And in my opinion, those are actually pretty darn useful. But as far as like explaining the code, it kind of clutters it up a little bit. So I am going to take out all of those prints when they're not necessary. I'm basically going to reduce this to just the prime bones so that you can see just the framework, so that we can talk about the very basic framework. All right, let me do that. All right, so I went through that master sketch and that slave sketch, and I got rid of actually a lot of really useful stuff about printing off error messages and some fallback measures in case you can't connect. I got rid of all that stuff so that we could trim this down to just the very minimum stuff it takes to set up ESPNOW. So if you're starting your own ESPNOW project, I'd actually go to that master sketch and that slave sketch, that basic example, and I would kind of start from there. Because again, it's got a bunch of useful functions in there to make things happen. The reason we're stripping that all away is so that we can see just the very minimum stuff that is required. These minimum functions. Now, all of the stuff we're going to talk about in here, all of the ESPNOW functions are actually referenced in the Espressif API reference for ESPNOW. So when I say, hey, this function does this function does that, they're all documented here on this webpage. I'll make sure to link to this documentation in the description below. But all of these functions, and you know what, there's only like 18 functions, so it's really not too much. But yeah, so it'll tell you, hey, what parameters do they take, what do they return, all this kind of stuff. So this is a really useful page to have. Okay, so let's go ahead. We're going to start at the top of the transmit sketch, that master sketch, and we'll talk about this ESPNOW stuff, what's actually going on. So the first thing we're going to do is include these libraries, ESPNOW and the Wi-Fi. Then we're going to set a channel. Your transmitter and your receiver need to be on the same channel. It actually defaults to channel 1, but we're going to just set it explicitly here. So one really important thing to understand about this ESPNOW protocol is that if you are the transmitter, you need to know some information about the receiver. Specifically, the information you want to know is the MAC address of the receiver, and the MAC address is going to be a unique network address that is like assigned to the hardware. It's not something you come up with, it's something that's already on the hardware. And that MAC address gets saved with the transmitter. And this data type right here, ESPNOW peer info T, this is where that MAC address is going to be saved, along with some other information about the peer. So we create a variable named slave, and it's of type ESPNOW peer info T. And if we check the reference and we come down to the very bottom, it defines this ESPNOW peer info. It's actually a structure, and it's got several members here, but this peer address, this is the MAC address that will be saving the MAC address of the receiver into this structure. Okay, so that's what this line of code is for. Okay, so this next line of code is the data that you want to send. Now here we've got an unsigned integer named data. We set it equal to 0, and this is what we're actually sending. It doesn't have to be, it could be anything, any type of thing. You could send a string, you could send a structure. As long as it's 250 bytes or less, you're going to be fine. All right, so far we've got the libraries, we set the channel, we set that storage place, we create, that variable for where we're going to store the MAC address info for the receivers that we find, and then we're going to just define our data. Like, what is the actual information we want to send? Maybe this is a sensor reading, or who knows, this can be whatever you want it to be. So now down in the setup, we're going to actually start calling some of these ESPNOW functions. So first thing I do is I start serial communication, not necessary for ESPNOW, but we're just going to use it to create some prompts for ourselves in the serial monitor window. Then we want to set the mode of the transmitter to be a station. So we want to put it in station mode. So we call the mode function from the Wi-Fi library, and we just pass it this Wi-Fi station. The transmitter should be in station mode. Then we call our first actual ESPNOW function, which is ESP-init. So this is what's going to initialize the ESPNOW protocol. And again, this function comes right from the ESPNOW API reference, ESPNOW init. So once we've initialized ESPNOW, the next thing we need to do is register a send callback function. So this is something we're responsible for. We've got to name it, and then we've got to actually create the function itself. And I'm just using the example that was provided by that master sketch. Let's take a look at the signature down here. And you can see every time this onDataSent function runs, all I'm doing is printing off a little line here. It says I sent data, and then it's going to print the data that was sent. You'll notice that the function signature has some stuff in it that I'm not even using inside the function. And again, that's because I was stripping this stuff down. But when you create your callback function, it's going to require 2 parameters in here. an error status code, and then it'll be expecting a pointer to your MAC address. I think it's easiest just to kind of use the template that they provide and then adjust it from there. The next thing we need to do is scan all the different Wi-Fi networks that are in range, and we need to find the one that we're actually going to transmit to. Now, this function right here, this scan for slave, is by far the most complicated thing going on in this sketch right here, okay? And I'm not going to dive in depth into this, but here's the basic concept. Recall that I mentioned if you're the transmitter, you need to know the MAC address of the receiver. So what you could do is you could just hard code the MAC address into this transmitter sketch. So if I knew the MAC address of my receiver, then I could hard code in the MAC address right into here, and I would save that MAC address info right up here in this slave variable. If you recall, that's where we're going to save the MAC address info. So I could totally do that, and it's easy to get the MAC address of the device. All you have to do is run this Wi-Fi.MAC address. You print it out to the serial monitor. So I could just run this on the receiver sketch. I could get the MAC address, and then I could just hard code that in here. But what I like about this scan for slave is that what it's going to do is it's going to go out and grab the MAC address for you. And the way it's able to do that is it actually looks for the network name of the target device. It looks for a matching network name, and when it finds that matching network name, then what it's going to do is save the MAC address of that matching network into the peer information. So that's what this scan function is doing. It's looking at all the networks available using this Wi-Fi scan networks. And this is a pretty cool function right here, this Wi-Fi.scan networks. This generates an array of information about all the networks attached. And then what you can do is you can iterate through that array, and you can get the SSID, the MAC address, which is the BSSID, and some other information using the scan networks. But that's essentially what's going on here. We're just getting the MAC address of that receiver device, and we're saving it. Okay, so that's what that does. So now that we've got the MAC address of the receiver, we're going to add it to our ESPNOW network by using the ESPNOW add peer function. And this function expects a pointer to our ESPNOW peer info variable right up here, right? So this structure up here, and this ampersand in front is what is basically saying, hey, we're going to pass the address in memory of where this is. Now, if you're not very familiar with pointers or referencing or dereferencing, I really wouldn't sweat it, because I think you kind of get the idea. Like, hey, this variable right here is where we're storing all the information about the receiver, and here we are going to add that receiver information as part of our peer network. Okay, so that's what's going on in setup. So we've set the mode of the transmitter into station mode. We do our ESP-init. We register a callback function. That's the function that's going to run every time we send data. Then we're going to find the MAC address of the receiver based on the network name or the SSID of the receiver, which we'll have to set in the receiver code. And then once we've got that MAC address, we add that receiver as a peer. Okay, so that's the setup, not too hateful. Now we go into the loop, and this is the function, ESP-now send, that we use to actually send our data to the receiver. So we need to give it the MAC address. So right here, peer address, slave.peer address, that's where we just got that MAC address. So we're going to send the MAC address. This is the data that we're sending. And again, we said data was 0. And then it needs to know the size of the data that we're sending. So this size of is going to return how many bytes are in data. And then the next thing we do is we increment data, and then we delay 3,000 seconds. So every time through this loop, we're just sending data. Okay, so I mean, there's, a lot going on here, but it's not too crazy. Let's just run through it one more time. So we add libraries, we set a channel, we say, hey, this is where we're going to save information about our peer. We create our data variable. In the setup, we're setting the transmitter into station mode. We initialize ESP-now. We register a callback function, and this is the function that's going to run every time we send data from the transmitter. Then we're going to scan all the available networks, and we're going to get the MAC address of our target receiver. And then what we're going to do is add that receiver as a peer into the network. Finally, in loop, what we're doing is we're using that ESP-send-now function, and we're just going to send that data to our receiver. We increment the data and then we delay. So, okay, now let's take a look at the receiver code. So here's the receiver code. It's all at 24 lines. We could probably make this even less perhaps, but so let's talk through this. So we're going to include these libraries, the ESPNOW and the Wi-Fi. We set the channel, and recall the channel needs to be the same for the transmitter and the receiver. In setup, we go ahead and start serial communication. And then for our receiver, we're going to set it in AP mode. Then what we do is we are going to configure the AP mode, and we are going to set the SSID to something that our transmitter is going to be looking for. Okay, so notice I named this RX_1. So this is going to be the name of our network, or our SSID. And if we come look over at the transmit code, at this master sketch, and we look at this scan for slave, what it's doing is it's looking for an SSID that starts with RX. And that's how we're able to identify our target devices, like our receiver devices, when we use that scan for slave function. Again, we could just hard code the MAC address of the receivers into our transmit sketch, but to me this is a nicer way to do it, because you don't need to know the specific MAC address of your targets. You just need to know the SSID. So let's say my dog ate this specific ESP32 receiver and I had to get a new one. I wouldn't have to figure out what the new MAC address is of the board I get. All I have to do is load this same code, and since I'm giving it this name, then the transmitter is going to be able to find the MAC address. Okay, hopefully that makes sense. I don't know. Next thing we're going to do is use that ESPNOW init function. So you saw this in the transmit sketch. And the next thing we do is now we register a receive callback function. And this receive callback function is a function that's going to run every time the receiver receives data from the transmitter. So let's take a look at this onDataReceive function. Notice it takes 3 parameters: the MAC address, the data, and then the length of that data. Those were the 3 things that we were sending in our send function. And this onDataReceive function is where you're actually kind of getting access to the data that was sent over the ESPNOW protocol. So here, all I'm doing is I'm just printing off hey, I just received some data, and I print off that value. But what is a pretty common thing to do is to save this data somewhere into the program so you can do other things with it later. You don't want to do a bunch of processing in here with data. Maybe I could multiply data times 25, turn on some pins based on the, what information I got back, or do something like that. That's not necessarily what you want to do in the callback function. You'd be better off copying this data into the program and then adjusting it in the loop, doing the actual stuff that you want to do with the data in the loop. And so one way to do that would be this. I'll just show you real quick here. All right, so now what I'm doing is I'm using memcopy, and that data that comes in, I'm saving it over to another variable called new data. And it's going to match this data right here, this data type or structure, whatever it is going to match what it is your data is over here, right? The type is going to match. And so you say, hey, I'm going to get some incoming data right here. This is the data coming in. I'm going to get this incoming data. I'm going to save it to new data. I'm going to copy it into new data, all that data. And then memcopy needs the size of what's going to be copied over. And we want to limit that to the size of the space we've allocated for that data we're going to write. Okay. And then in the loop, what I can do now is I can, transform that data somehow. So here I'm just multiplying new data times 5, and that's it. But you could be turning pin numbers on or doing any number of things with that new data. It's just you don't want to do a bunch of different stuff with that new data inside your receive callback function. And that is pretty much it for the receiving device. So what I'm going to do is I'll open up the serial monitor for both of these, and we'll see how this is working. All right, so now what I've done is I've pulled up Arduino IDE 2, which is kind of nice because you can set up 2 different port targets. You can have 2 different boards connected and simultaneously have the different serial ports open. So I've got the transmitter over here and the receiver over here. And we can see, I can say, hey, I'm sending my data 158, and then we can see I just received 158, and then it's doing something with it. It multiplies it times 5. So this is pretty much how it works. Now, I know that's like, man, that's a lot of stuff to go through for a really, this is a pretty simple example, right? We're just sending one integer, but I'm telling you, I'm thinking the more I've been working with ESPNOW, the more I think this is a completely underutilized feature of ESP boards. And before I go, I just want to show you this little project I've been working on that's been really fun, and it is using this ESPNOW. All right, so what I've got here are 2 devices. They both have NeoPixel strips attached. So I'm using the Fast LED library, and this is like the transmitter device. There's ESP32s attached to some NeoPixels on both of these. So this is the transmitter device, and this is the receiver device. And I'm using this to send a specific color to these NeoPixels. All right, so right now it's just in kind of standby mode. This is a rotary encoder. I'll just press it, and now I go into selection mode. So you can see as I turn the wheel and I select these different colors, that I'm using that send function just like we demonstrated here, and that data is getting sent over to this device on this ESPNOW network, right? So let's say like, oh, what do I like? I don't know. I like this blue color, right? So I select that. Now I can select the brightness, right? I can make it, or the saturation rather, I can make it less or more blue. So I'll just, go with max blue, and then I can set the brightness. You can see like that. Maybe I don't want it bright at all. And then I can send that. And now this stays that color, and then this goes back into standby mode. But you can see like, when we're just sending stuff over the serial monitor, that's pretty boring. But once you start playing around with like, wow, there's a bunch of cool stuff I could do with this. Now this, it's just somewhat trivial. It's kind of fun to mess with. But you can imagine with a sensor network, you could have all types of interesting interactions taking place just by, using a couple of these functions to send and stuff. So hopefully you realize like, man, there is a ton of potential. And I really feel, maybe I mentioned it already, but I really feel like this ESPNOW is a totally underutilized feature of these ESP boards that are so common anymore. All right, well, hey, I hope you found this helpful. If you have any questions or comments or thoughts, make sure to leave them in the comments. We really do our best to answer all the comments. Another shout out to our sponsor, Altium. If you want to get a free trial of their really cool software, their PCB design software, just check out our link in the description. Also, while you're down there, subscribe to the channel, like this video. It really helps us get the word out about what we're doing. And finally, if you want to jump in to this Arduino stuff and really start understanding all the details, like maybe you've been watching this video and you're like, I'm not sure I get that part or this part, check out the training that we offer at Programming Electronics Academy, and it's going to get you up to speed with all this type of Arduino programming stuff. Thanks a lot, and I'll see you next time. Bye.